radiation pressure or pressure by EM wave. Whenever the electromagnetic wave is incident on the surface, it always exerts the pressure on the surface, and this pressure is called the radiation pressure or the pressure exerted by the electromagnetic wave. As we know that electromagnetic wave are nothing but this is the beam of the photons. So this pressure is the consequence of the conservation of the momentum of the photon. The pressure exerted by incident electromagnetic wave is the consequence of conservation of momentum of the photon. We know that the photon has the momentum. So momentum of the photon this P equal to h upon lambda. H Planck's constant, lambda de Broglie wavelength. De Broglie wavelength. So when the electromagnetic wave is incident, it means that some light is incident on the surface, then it exerts the pressure. So this is due to the momentum of the photon. So pressure P is equal to F upon A. Force upon area. F the force, A area. So now this pressure equal to P equal to I upon C. I the intensity of the, so now this pressure can also be expressed in this way. So I the intensity of EM wave and C speed of light. Speed of light. So the general formula for this pressure is P is equal to 1 plus alpha into I upon C. This is now a very general formula where alpha equal to coefficient of reflection of the surface. For perfectly black surface, this P is equal to I upon C, as alpha is equal to 0, because perfectly black surface will not reflect the radiation. So if suppose we are having this surface like this and the wave is being incident on it, then this is now wave, then this will be completely absorbed, so there will be no reflection from this surface. So this is now surface, and this is now perfectly black surface, This is now wave. So the pressure is so much. For perfectly reflecting surface, to I upon C, because this alpha equal to 1. So what will be there, that this is now suppose surface, this is now incident, then this will be reflected. So this is the incident, this is now reflected, then we will have the alpha equal to 1. For the remaining surfaces, alpha is not equal to 1, so alpha is between 0 and 1. Reflecting surface. So alpha is greater than 0 but less than 1. So for different surfaces you can have the different values of alpha, and then you can find the pressure exerted by the electromagnetic wave on the surface. If suppose this is oblique incidence, of EM wave. Oblique incidence means that suppose this is now surface, and this is now radiation being incident, so this is the normal, it is being incident at this angle theta, this is now normal, this is the incident radiation. Then what we have, that this P is equal to I upon C cos square theta. So this P is proportional to cos square theta. Theta the angle between the normal of the surface to the direction of the incident radiation, as we have shown in this figure. So now before that you can have that if theta equal to 0 degree, then this P is equal to I upon C. That is what we called it. I told you earlier also. Now if theta equal to 90 degree, then P is equal to 0. 90 degree means it is parallel to the surface, then it will exert no pressure on the surface. For all other remaining angles, that this P will vary according to the value of the theta. So for different values of theta, the P will be the different one. So here for the oblique incidence of this radiation, this P depends upon the angle. So this is now cosine of this angle theta. So P is proportional to cos square theta. This is now surface. And you can see from here that it is independent of the nature of the surface. So this pressure exerted does not depend upon the nature or the geometry of the surface. The pressure exerted by EM wave does not depend upon shape or size of the surface. So for whatever is the surface, that it will exert the pressure whenever this is made incident on the surface. So this is about the radiation pressure exerted by the electromagnetic wave. So thank you very much.